Welcome, and today we're exploring the intriguing question, what if gravity was 10 times stronger? Are you a fact enthusiast? Do you have an insatiable curiosity? Then why not subscribe for more videos like this one? And don't forget to hit the bell for more captivating content. Our understanding of gravity begins with Sir Isaac Newton's law of universal gravitation, which states that any two objects exert a force of attraction on each other. The strength of this attraction is determined by multiplying their combined masses and the gravitational constant, and then dividing by the square of the distance between the two objects. It might sound complex, but it's a formula that essentially explains why our lives, our planet, our galaxy, and our universe are structured and positioned the way they are. Generally, the force of gravity between any two objects is quite weak. However, its effects become much more noticeable when very large masses are involved. Given that the Sun makes up more than 99% of the solar system's total mass, it has the strongest gravitational pull in our corner of the Milky Way galaxy. As a result, Earth, along with all the other planets and everything else in the solar system, orbits around the Sun. Meanwhile, Earth's core, although not nearly as powerful as the Sun, exerts a gravitational pull that attracts nearby objects to its surface. This includes the Moon, which remains in orbit thanks to its own gravitational force, which also causes tides on Earth. Everything on Earth, from tree roots to the cells in our bodies, is held in place by the planet's gravitational force, which is calculated to be 9.8 meters per second squared, or 1 g. So, if Earth's gravity suddenly increased tenfold, everything would change, and not in a good way. Assuming that the force increased without any changes to Earth's general composition, a 10 g scenario would mean that everything within Earth's gravitational influence would weigh 10 times as much. While mass remains constant regardless of an object's location, weight changes depending on the gravity acting upon it. The feeling of weightlessness associated with space travel is a direct result of weaker gravity. But in this scenario, we'd be at the opposite end of the spectrum, with Earth's new gravity making everything feel 10 times heavier. Imagine a 200-pound person suddenly feeling as if they were carrying an extra 1,800 pounds of weight, and then apply this incredible burden to the entire planet. Even taking a single step would become a Herculean task. It simply wouldn't be possible. Even if you survived the initial impact with the ground, the human body would more or less instantly begin to fail. Our bones would be crushed, and the heart would have to beat faster to keep blood flowing through arteries and veins, which, you guessed it, are also being crushed. In a 2018 study at the University of Zagreb, 3 physicists sought to determine a gravitational range that the human body could survive. They estimated that a specially trained athlete could potentially function at up to 4 times our current gravity. But once this threshold is exceeded, even the fittest human body would be unable to lift itself off the ground. Of course, while our own brutal biological struggles are unfolding, the material world around us would also be in chaos. Planes would fall from the sky, cars would come to a standstill on roads and bridges that would crack and collapse, trees would fall over, and buildings would crumble. Further afield, artificial and natural satellites would need to somehow start orbiting the Earth at 10 times their current speed. If they couldn't, they'd be close enough to be pulled in and collide with our increasingly doomed planet. Due to the vast distance between them and the Sun's much greater mass, Earth's increased gravity shouldn't drastically alter its relationship with the Sun. However, the shift could potentially push Earth out of the solar system's habitable zone, meaning that its climate would also become increasingly unstable. While all this is happening, though, Earth's basic credentials as a planet would have increased. Celestial bodies are considered planets when they have enough self-gravity to maintain a spherical shape. So with 10 times the force, what's left of Earth is pulled closer to its core, making it arguably more planet-like than ever before. Suppose the change isn't confined to our single planet, and gravity is universally multiplied by 10. We'd see similar effects elsewhere. The solar system currently exists in a near-perfect balance, allowing for one-to-one gravitational relationships between various bodies that maintain a steady equilibrium. A significant shift in gravity would disrupt this balance as the planets move closer together to try and maintain their orbits. Even the Sun itself could struggle under the new conditions and burn out faster, and that's just one star in one system. Elsewhere, other stars and entire galaxies would be pulled closer together, potentially causing the entire universe to either reverse or significantly slow down its current expansion. Finally, this scenario assumes that the increase in gravity happens now, rather than at the beginning of everything. Although much remains a mystery, the Big Bang Theory is widely accepted as the most plausible explanation for the creation of the universe. It suggests that the cosmos began as a single, incredibly dense point before triggering an explosive expansion that continues to this day. But would such an event have even been possible if the force of gravity was 10 times stronger from the start? As the trigger for the expansion is still unknown, it's impossible to say for sure, but dramatically increased gravity isn't likely to have made the process any simpler. As an inherent, fundamental part of life, we often take gravity for granted and don't often stop to think about how crucial it really is. But it's a major reason why Earth can maintain its status as a habitable planet. Although a small increase or decrease in gravity might be manageable, humanity could only withstand so much pressure before succumbing to the strain. And that's what would happen if gravity was 10 times stronger. What do you think? Is there anything we missed? Let us know in the comments. Check out these other clips from Unveiled, and make sure you subscribe and ring the bell for our latest content.